Hello and welcome to Mr. Tompkins EdTech. With 2 papers down and 1 to go, many of you have been asking about my predictions for topics likely to come up in paper 3. So I thought I'd make this quick series of videos compiled from questions covered in my practice papers and past paper walkthroughs. In each video I've taken one topic I think is a dead cert to come up on paper 3 and created a compilation of all the questions I've recorded on just that one topic. Okay, question 19. Why W is directly proportional to Y and W is inversely proportional to X squared. And part A wants us to find W when Y is 9, and it gives us a pair of values for Y and W that go together. Okay, let's start off with the relationship. W is proportional to Y, which means W is equal to K times Y. Now we're given 2 values that go together, so when Y equals 4, W equals 14, so we can sub those in to find K. So 14 equals K lots of 4. Rearranging for K, K is equal to 14 over 4, which is 7 over 2. Okay, so W equals 7 over 2 lots of Y. Okay, we still need to work out the value of W when Y is equal to 9. So subbing that into the equation, so when Y equals 9, then W is going to be 7 lots of 9 over 2. 7 9s are 63, so that's 63 over 2, which is 31.5. Part B is to do with the relationship between X and W. Now you'll remember that W is inversely proportional to X squared. So let's write that down first. W is inversely proportional to X squared. Okay, so we're then replacing that little proportionality symbol, making it an equation. We get W equals K over X squared. We've got a pair of values that go together which can help us find K. So using the fact that when X equals 2, W is equal to 5, we can say that 5 must be equal to K over 2 squared, which is 4. Cross multiplying that, I get K equals 5 times 4, which is 20. So our final equation is, I don't know, space on this one, is W equals 20 over X squared. Now asks us to work out the value of W when X is equal to 10. So subbing in when X equals 10, W then is going to be 20 over 10 squared. 20 over 10 squared is 100, so I'm going to get 20 over 100, which is 2 over 10, which is 1 over 5, 1/5. So the answer is W equals 1/5. Question 4. Y is directly proportional to X and K is a constant. Circle the correct equation. Okay, so if Y is directly proportional to X, then Y equals K times X. This one here. Question 25. The time of each swing of a pendulum, length L centimeters, is T seconds. T is directly proportional to the square root of L. When L is 64, T is 1.6. Work out the value of T when L is that number there. Okay, so let's start off with the proportionality. We are told that D is directly proportional to the square root of L. So let's write that down. T is proportional to the square root of L. Next step, we can replace that proportionality with equals k lots of root L, like that. We're told a pair of values that link L and T together, which we can use now to evaluate k. So when L is 64, T is 1.6, which means that 1.6 equals to k lots of root 64. So the root of 64 is 8, so 8k is equal to 1.6, and then dividing both sides by 8, we're going to get 0.2 is equal to k. So therefore our complete equation is t is equal to 0.2 lots of root L. Now we know that, we can work out the value of t when L equals 132.25. So when L equals 132.25, just sub that in. T then is going to be 0.2 lots of the root of 132.25. So reaching for the calculator, 0.2 times root 132.25 gives me 2.3. So t is equal to 2.3. Question 22. The value of a car in V pounds after t years is modelled by the equation V is equal to A times k to the power of minus t, where A and k are constants. The value of the car when new was £22,000, and the value of the car after 2 years is a 14,080. Work out the values of A and k. So the first line here, this tells me that when t is equal to 0, V is equal to 22,000. So I can sub those values in. So 22,000 is equal to A times k to the power of minus 0. Now, k to the minus 0, anything raised to the power 0 is 1. So that'd be 1 lots of A. So actually that's just A, isn't it? So A is 22,000. And then the value after 2 years is 14,080. So subbing those two values in as well. So if I've got 14,080 is equal to A, we've just discovered was 22,000, times K raised to the power of minus 2 then. So what's that then? So K to the minus 2 is, just going to write that out again, it's 22,000 divided by K squared. There's another way of writing a negative power. I think that just makes it a bit clearer how I'm going to then rearrange this. I'm going to move that over there and then other number down. So K squared is equal to 22,000 over 14,080, and so therefore K is going to be the square root of that. So 22,000 divided by 14080 and then square rooted is 1.25. Okay, so A was 22,000 and K was 1.25. Question 13. Here is a formula, S equals 5t squared, where S is the distance in meters a ball falls when dropped and t is the time taken in seconds. In part A, we're told that a ball is dropped from 2 meters above the floor. We need to work out the time taken for the ball to hit the floor. Okay, so we know that S is equal to 2, isn't it? So S is the value we've been given. So subbing that into our formula, we've got 2 is equal to 5t squared. So we're going to have to rearrange this to find t. First we can cross multiply the 5, which gives us 2/5 is equal to t squared. find t, we need to square root both sides, so t equals the square root of 2/5. So root 2/5, which my calculator says is about 0.632 seconds. 0.632 seconds. Okay, and part B says which of these statements is true for the ball. Basically, we need to decide whether or not it falls exactly the same, exactly twice, less than twice, or more than twice the time it takes for it to fall the first meter. So we already know how long it takes to fall 2 meters. Let's go back and work out how long it's going to take to fall the first meter, and then we can compare them. So remember, s equals 5t squared. So if s equals 1, then 1 equals 5t squared. So then, rearranging like we did before, 1/5 is equal to t squared, and therefore t is equal to 1/5 all square rooted. So type in square root of 1/5 into the calculator. I get 0.447. So comparing that with 0.632, you can see it's taken less than double the time to fall, because if it took exactly double the time, it would be 0.447 times 2, which would be 0.89 something, and it isn't that much. So it must be that one there. Question 9. We're told that y is directly proportional to x, and we've been asked to complete the table. Now, if y is proportional directly to x, then y is going to be equal to k lots of x. K is some constant that we can find. Now we've got a pair of values that go together here. When x is 7, y is 63, so let's sub those in. So when x is 7, y is 63, so 63 is equal to k lots of 7. So that makes k equal to 63 divided by 7, which is 9. So our full equation is y equals 9x. So now very simple to fill out the rest of the table. If x is 0, then 9x is 0. If x is minus 8, then 9 lots of minus 8 is minus 72. All done. Question 13. Y is inversely proportional to x for positive values, and we're given a pair of values that go together. Okay, so y is inversely proportional to x, which means y is equal to k over x. So we're given a pair of values that go together. That should be enough for us to evaluate what k is. So when x equals 3.5, y equals 4.2, this tells us that 4.2 is equal to k over 3.5, making k equal to, I make that 14.7. So now we've got the equation that links y and x together. So therefore y is equal to 14.7 divided by x. So now we need to work out y when x is 5.6. So when x equals 5.6, then y is going to be 14.7 divided by 5.6, which apparently is 2.625. So y is going to be 2.625. Okay, in question 13b, we're asked on the grid, draw a sketch to show the relationship between y and x. So we just found that y is proportional to 1 over x. So it's going to be some sort of reciprocal curve And all our reciprocal curves have a basic similar shape, and they look like this. So we just need to make sure we draw our line so that it is approaching the axes, but never touching them. Now, mostly they have another section down here, but in this case we're told everything is positive, so it only exists for the positive values of x. So that's question 25. The number of bacteria n after t hours of an experiment is given by n is equal to a times 2 to the power of t over 4, where a is constant. At the start of the experiment there are 250 bacteria. Show that a is equal to 250. Okay, so at the start of the experiment then t is going to be equal to 0, isn't it? And we know that the number of bacteria n is 250. So subbing those two values into our formula gives me 250 is equal to a times 2 to the power of 0 over 4. So 0 over 4 is 0. 2 to the power 0, any number raised to the power 0 is 1. So that does imply that a is 250. So question 25b, how long is it before the number of bacteria doubles? So our formula now is 250 times 2 to the power of t over 4. And when is that going to be equal to 500 then? Well, I can see that 250 times 2 would be 500. So when is 2 to the power of t over 4? When's that going to be equal to 2? Well, that's going to be equal to 2 when t is equal to 4 then, isn't it? Because I've got 4 divided by 4 would be 1, and 2 to the power 1 would be 2. So that means that t would be equal to 4. So t is 4 is the solution. And then finally, Megan works out that there will be more than 1 million bacteria after 2 days. Crikey. Is she correct? You must show your working. So if you remember that n is equal to 250 times 2 to the power of t over 4. Now, after 2 days, what does t represent? T represents hours, doesn't it? So, after 2 days, we're talking t is equal to 2 times 24. That's 48 hours. So, n then is going to be 250 times 48 over, sorry, it's going to be times 2 to the power of 48 over 4, which is 250 times 2 to the power of 12. So 250 times 2 to the power of 12 is 1024000. So yeah, that is more than 1 million. So she is correct. Question 22. A ball is dropped vertically. It falls d meters in t seconds. D is directly proportional to the square of t. The ball drops 45 meters in the first 3 seconds. How far does the ball drop in the next 7 seconds? Okay, so we've got a fairly straightforward proportionality question here. Let's start off with the relationship. We're told that d is directly proportional to the square of t. So d, little fishy, t squared. Okay, so once I've written it down like that, d is proportional to the square of t, I can replace the little fishy with equals k and evaluate what k is. Okay, so I've used this bit of information here already. So that was to give me the relationship. Now, with these proportionality questions, you're always given a pair of values that go together, and the reason you're given that is that you can use it to evaluate your constant. So you're going to sub those two values in, and you're going to use it to find k to complete the equation that links d and t together. Okay, so when, well, what is 45d? That is when d equals 45, t is equal to 3. So 45 equals k times 3 squared. Okay, so 3 squared is 9. 45 divided by 9 is 5. So k is equal to 5. Okay, so now I've found what k is, I can replace it back into my equation here, look, to find the relationship between d and t. So therefore d is equal to 5t squared. Okay, so that's my complete equation now. Once I've got the complete equation, I can then go on to use it to work out any other value of d given t or t given d. Now what it's asking us to find here is how far does the ball drop in the next 7 seconds. Now notice next is in bold, so again, if you're not careful, you'd have just read 7 and shoved that into the equation, but that is not the case, is it? You've got the first 3 seconds and then the next 7 seconds, giving you a value of t is equal to 3 plus 7, it's 10 seconds. So you're evaluating this at the point t is equal to 10, not 7. So what is d when t is equal to 7? Well, 10's a whole lot easier to square. 10 squared is 100 and times 5 is 500, isn't it? So it's 500 what? 500 meters. Okay, so you think you might be done now. Don't just write down 500 meters in the answer line though, because that would be a terrible, terrible mistake. Now, again, there's a bit of a sting in the tail of this one, isn't there? Because the ball drops 45 meters in the first 3 seconds. How far does the ball drop in the next 7 seconds? Now, we've evaluated that at time t equals 10, d is equal to 500. But at time t is equal to 3, d was equal to 45. So how far does the ball drop in the next 7 seconds is the difference between those two. So our answer then is going to be the difference of those, isn't it? So 500 subtract 45 is 455 meters, which is my final answer, 455m. Which just goes to show, beware of anything in bold in the question. Just really think around those, because if it's in bold, the examiners are basically flagging up that there's a bit of a sting in the tail. Question 14. We're told that x times y is equal to c, where c is a constant. Now rearranging that for y, that would tell me that y is equal to c over x, which means that y is proportional to 1 over x. So y is directly proportional to 1 over x. It's that one there. Now if y is proportional to 1 over x, you can say that y is inversely proportional to x, but you cannot say y is inversely proportional to 1 over x. That makes no sense. So don't be tricked by that. Y is directly proportional to 1 over x, or y is inversely proportional to x. Check out my other predictive topics by clicking on the card appearing here. Also, you can check out my practice paper walkthroughs by clicking on the card here, or you can even go through actual past papers by clicking on the card over there. Good luck in your exams, and I'll see you next time.